Hello, our objective is to develop a pH measuring system for the fish hatcheries. Our aim is to create a system which is cost efficient and it makes sure that it meets the current standards of the industry. Another objective is to display the real-time reading of the pH sensor on our devices using IoT. We have simulated the proposed system using Proteus software. Four components are used: Raspberry Pi, 16 cross 2 LCD module, analog to digital converter, and the pH sensor. Actually, there is no inbuilt pH sensor in Proteus, so we have used rheostat for the simulation purpose. The sensor is given a voltage supply of 3.3 volts, and its ground pin is connected to ground, and the data of data analog data coming out from it is given a label of AN0, and the analog out pin of the sensor is connected to ADC module through channel 0, as both the pins are given common label name. Again, the ADC module is given a supply of 3.3 volt and its ground pin is connected to ground. And the reason why we are using the ADC module is that the Raspberry Pi does not have an analog to digital converter built in it. As a result, we are using the ADC module, and the ADC module communicates with the Raspberry Pi using SPI communication model. So the four pins of SPI are uh, the clock pin, the master out, slave in, master in, slave out, and the slave select. And then uh, we have chosen Raspberry Pi as our microcontroller. And as you can see here, the pin number 19, 21, 23, and 24 are given the same label as in the ADC module. As a result, these pins are connected. And then we have the 16 cross 2 LCD. So here the its VDD and read write pin are grounded, and register select and enable pin are connected to general purpose input output pin number 22 and 23 of Raspberry Pi, and the last four data pins are connected to the pins of 4, 17, 18, and 27 of the Raspberry Pi. And the code for the simulation is as shown here. At the beginning, the required modules are added. Then the initial settings of the general purpose input output pins of the microcontroller used are given. The initial configuration of SPI is specified here to make the code more reader friendly. The pin numbers are given uh, easily understandable variable names. Then few constants are defined here. Fine. Then the LCD pins are set as output pins. Um, and a few constants related to LCD are also defined, such as the width of the LCD, the address of the first line and second line, and so on. Then few functions are defined. The highlighted function is used to initialize the LCD. Then the next function is to read the byte data and convert it into bit data. Then, as we know that the LCD processes the data when enable pin is high. So when the LCD is about to process the data, enable pin is set high. Other time, enable pin is set low. Then a function is defined to display the message on the LCD. Then the data is read function is defined to read the data from the ADC module. and convert the analog data into digital data. As 3.3 volt is supplied, we are giving 330 millivolt value here. And since the ADC is 10 bits ADC, so it is divided by 1023, which is 2 to the power 10 minus 1. And then finally, we are setting up the conditions. So first, initially, uh, when the simulation is run, the string hello gets displayed, and after 2 seconds, the pH value gets displayed in the following format. That is, it displays pH sensor reading string followed by the pH value. Now I'll run and show the simulation. As you can see, initially hello gets displayed, and after 2 seconds, the pH value gets displayed. On clicking display symbol in pH sensor, the reading gets increased, and on clicking this minus in pH sensor, the reading gets decreased. Thank you.